Hello students, Mr. Brown here, and today we are taking a look at a website called the NMRium. This website lets you predict the NMR spectra of many different molecules, any molecule really, and offers a lot of customization parameters with which you can adjust your NMR spectra. I'm going to show you the simple way to use this website for the lab that I'm asking you guys to do, and give you some tips and tricks on how to get the information that you need. So when you click the link and open the website up, this is the page that you're brought to, and you want to go ahead and make a few adjustments. Over here where you see the tabs that say information, peaks, processing, integrals, ranges, multiplet analysis, and chemical structures, you want to go ahead and click the X's beside the information, peaks, processing, integrals tabs. We're not going to be using those for the lab. If you want to look at how they are used later on your own time, be my guest. Those are some really cool features of this program, and I may do a video later on explaining some of those advanced features, but that's not for this work here. So you can open and close these windows or tabs by clicking on the titles themselves. And to do your first molecule, you want to open the chemical structures tab down here at the bottom, and you'll notice inside the box it now says click to draw molecule. When you click it, it brings up a molecular editor with which you can input any molecule. So I'll start with a molecule of propanol, N-propanol, where the hydroxyl group is on the end of the chain, not isopropanol, where it's bonded to the middle carbon. And then I'll click save, and now as you see that it puts that chemical structure you drew down there in the box, and we are going to look along this bar here for the little symbol that looks like an NMR signal, and if you hover over that you can see it says predict spectra. So we're going to click predict spectra, and it will bring up a window and it will give you some options. You can name the prediction if you feel like. You can name it the name of the molecule or give it some other name to help you keep things in order. And then you can choose the frequency of the instrument that you want to use to predict. So for our models, you definitely want to choose 2, 3, 4, or even 500 megahertz. That's kind of getting into the really advanced kind of side of things. Not to say that it won't give you a better spectra. It's just that maybe it's a little unrealistic. If we actually had an NMR here, we'd be lucky to have like a 200 or 300 megahertz machine. So if we send a sample off somewhere, we might expect to receive it back in 200, 300, 400 megahertz. You can certainly do the 1200 megahertz instrument or run the 1200 megahertz instrument. This is just a predictor after all. However, it's not very realistic. There's not many of those instruments in operation, and you're not really going to have access unless you are working on the cutting edge. But if you want to, nothing's stopping you. To get a kind of a more realistic view, I would say definitely go over 100. Those instruments are a bit outdated now, but stay under 500 to kind of have a middle of the road, actually have access kind of experience. So I believe I ran the models on these on the 500 megahertz setting, and then you can make sure you have some things checked. We are only going to work with the 1H NMRs. We're not going to do C13 NMR or any of the other analysis that the NMRium offers, because we haven't covered those in our teachings as of yet. And you will need to confirm that you are sending this information out to different servers for analysis. So we're not doing anything classified or proprietary, so that's not really a concern for us. Then you can click the green Predict Spectrum, and you will see the results. Now I picked propanol or an alcohol really to begin with. One drawback of this prediction suite is that it doesn't handle labile protons very well, protons that are easily exchanged, and that includes hydroxyl protons. So for the assignment, I've steered away from using any hydroxyl protons, but regardless, this still gives us a good view of what we see. Other than that one proton, it gives us a good view of the signals that we see when we click this predict spectrum. And you can see a couple of characteristics here. So you can actually minimize the spectra window now. Once you get multiple spectra, you can switch between the different ones that you have predicted in this window here. But we only have the one for the moment, so we'll close that up. If you look at the ranges / multiplet analysis screen, you will see as you drag your mouse over, you can see a couple of changes. It displays the carbon that the hydrogens bonded to it are related to the highlighted peak, and it tells you how many relative hydrogens are at that peak, so it gives you the relative integration there in the next box. It tells you the multiplicity of that peak, so it puts a T here for triplet, it puts a QT here for, this is actually a quartet split into a triplet because this has two different kinds of neighbors, and this has a triplet because it only has the two neighbors in the other position. So you can kind of see how as you scroll through each peak, it highlights the carbon on the structure down there for you. It tells you the multiplicity of the peaks, and it gives you the relative hydrogens of those peaks. It also gives you an exact number for the parts per million for the delta measurement of that peak. Furthermore, you can also zoom in. So if you see me dragging my mouse across the screen here, as long as you have the magnifying glass here highlighted, if you want to zoom into one of these peaks, you can click and drag and look, and it will zoom in on the peak specifically that you've dragged onto. If you want to zoom back out, you can use the zoom out vertical button there. Quickly, you can run your own peaks and integrations by using the tools on the side there. So if you say you really want to do your own integration on a more complicated peak, this is something you would do if you had more of a complicated molecule. We would zoom in on a particular peak, maybe even again zoom in real close, and to do our own integration, you can slide from here through all of those peaks. And it will integrate them for you. That's kind of a bad view. But yeah, so you can set your own integrals if that's something you're interested in. Of course, that's getting into those advanced. Now you can open up the integral screen and see the integral that you set yourself. We can delete it and do it again if that's something we're interested in. But that's a little bit of the advanced features. I may go in, like I said, into those a little bit on a separate video, but for this assignment you really will just need to know how to get to the ranges and multiplet analysis table here. That will allow you to evaluate which carbons are giving us signals, and it gives you how many relative hydrogens are there at that position, and it gives you the multiplicity as well. So that's just a short introduction to the NMRium web tool. I hope this has been informative for you, and I hope it helps you answer the NMR lab that you will be working on.